All right, so let's practice some more. So we're doing higher order derivatives, and we're having to practice chain rule, product rule, all that kind of stuff in the process. So I have a 7x squared plus 7 raised to the 7/2. So my bigger picture is as I've just got a single chunk raised to the 7/2 power. So I'm going to have to use the power rule and the chain rule. Okay. So my power rule says drop my 7/2 out front times what's sitting there plus 7 raised to the 5/2, because 7/2 minus 1 or 7/2 minus 2/2 is 5/2, times the derivative of the inside, which is a 14x. Okay, so I'm done with my first derivative. I'm going to clean it up just a tiny bit, so I'm going to do a 14 times 7, which I don't know what that is. I pretty much do, but I don't know. So 14 times 7 is 98. All right, so my cleaned up first derivative is 98 over 2x times 7x squared plus 7 to the 5/2. So now I've got to do product rule, because I got variables times variables as my bigger picture. Okay, so that's my first derivative. My second derivative is going to involve, like I just said, it's going to involve product rule, and then I'm going to have to do some chain rule on the inside. So I've got the first, which is 98/2 x. What? That reduces to 49. All right, so 49x, okay? So I've got the first times the derivative of the second. So the derivative of the second is 5/2 7x squared plus 7 to the 3/2 times the derivative of the inside, which is 14x. Okay, so first times derivative of the second plus the second, which is going to be 7x squared plus 7 to the 5/2 times the derivative of the first, which is 49, because that's reduces, I wasn't paying attention, sorry. That reduces to 49. So if you want to clean it up just a hair, this isn't going to clean up. So I've got a plus, I got a plus 49 7x squared plus 7 to the 5/2, but this part cleans up. This 2 and this 14 reduced to a 7. So I have a 7 times 5 times 45 or 49. So 35 times 49 is 1715. So I have 1715. So that's this one, and those. I got an x squared. And I got a 7x squared plus 7 to the 3/2. So that is your cleaned up second derivative. That is your cleaned up second derivative. All right, more practice. So I have y equals x times x squared plus 2 squared. Okay? And I want to find a first derivative and a second derivative. Now, this one is not hard. You could actually expand this, meaning I would do x squared plus 2 times x squared plus 2. I would get x to the 4th plus 4x squared plus 4. Okay, now I can distribute this x through. So now I have x to the 5th plus 4x to the 3rd plus 4x. So all I've done is rewritten my original function. And now instead of doing product rule, chain rule, all that kind of stuff, all I got to do is go term by term like we were doing at the very start. So my first derivative is going to be 5x to the 4th plus 12x squared plus 4. And then my second derivative is going to be 20x to the 3rd plus a 24x. Okay? Now, if you wanted to go back and forth and do that, you can. I mean, if you're just looking for, I see the pattern of product, okay, then you can do it and it'll be just fine. But this is a small enough exponent that it doesn't hurt to do the algebra first. All right, let's do it again. So now we're going to do some quotient rules. So far we've done term by term using power rule. Then we've done multiplication using product rule and chain rule. And now we're going to do some quotient rule. So I have h of x equals x over 4x plus 5. Okay, so I know I've got to do quotient rule because I've got variables divided by variables. So my first derivative is going to be the bottom, which is 4x plus 5, times the derivative of the top, which is 1. So bottom times derivative of the top minus the top, which is x, times the derivative of the bottom, which is 4, all over the bottom squared. So these two things fall off. So my cleaned up first derivative is 4x plus 5 squared under a 5. Now, you can handle this two different ways. I can bring this denominator up top, and I can just do some with a negative exponent. So I could rewrite this as a 5, 4x plus 5 to the negative 2, and now I can just do another derivative. Okay, or you can do quotient rule again, knowing that this will zero out one of your terms. So it's up to you. Part of my job is to teach you what's the fastest, easiest way out. Okay, and it literally just depends on which way you want to go at this point. I would rather do it this way because I'll be done in one quick step. So my second derivative, again, you can do quotient rule here. Okay. All right. So, sorry, I got interrupted. So we're going to take another derivative. So I'm going to drop my negative 2 out front. I'm going to get a negative 10 times what's sitting there. Drop my exponent by 1. And then times the derivative of the inside, which would be a negative 40, 4x plus 5 to the negative 3. Or you could write negative 40, 4x plus 5 to the positive 3. But you just need to realize that this way is just as fine as this way. Okay, so there's that one. So let's do another few. Get you going. So we have g of u is going to be the square root of 14 minus 5u, which I'm going to rewrite as 14 minus 5u to the positive 1/2 power. Okay, so I'm going to find my first and second derivative. Okay, so I'm taking a first derivative. So I'm going to drop my exponent out front. So that gives me a 1/2, 14 minus 5u to the negative 1/2 times the derivative of the inside, which is negative 5. So when I clean that up, I get a negative 5/2 times 14 minus 5u to the negative 1/2. So now I can take a second derivative. So my second derivative, drop your negative 1/2 out front and watch your signs. So when I multiply that, I get a positive 5/4. Positive 5/4. 14 minus 5u to the negative 3/2 times the derivative of the inside. So if you wanted to clean it up, negative 25/4, 14 minus 5u to the negative 3/2, which also means you could drop this 14 minus 5u down into your denominator, and it would be raised to the 3rd power, but you're taking a square root, which means you could simplify it from there, which means it's too hard. It's not too hard. It's just more stuff to do when this is acceptable. Okay, not too hard, but we're lazy math people. All right, so I want to find higher order derivatives. So I'm given a polynomial. So this one, we're not going to just do the first derivative and the second derivative. We're going to keep going. So I've got a 9x to the fourth minus a 3x to the third. And I want to find the first, second, and third derivatives. So since this is a polynomial, I know I can just start diving right in and go term by term. Okay, so drop your exponent out front. Drop your exponent by 1. Drop your exponent out front. Drop your exponent by 1. So there's your first derivative. Second derivative, 36 times 3 is 108x squared minus 18x. Third derivative is 216x minus 18. And you're done. Okay? So if I want to practice some more, I got a 5x to the fifth minus a 2x to the fourth plus an 8x squared minus 3x plus 7. Okay, so my first derivative, my instructions are just find the third derivative, which means I got to find the first and second first. So I got a 25x to the fourth minus an 8x to the third plus a 16x minus 3. My second derivative is 100x to the third minus 24x squared plus 16. And now my goal was to find my third derivative, so I have 300x squared minus 48x. And we're done. Okay, so you just want to keep going through it. All right, so for number 13, my function is 5 over x squared, and I want to find a third derivative. Okay, which means I don't want to do quotient rule on this because I can just as easily bring this up with a negative exponent. So I'm going to rewrite him as x to the negative 2. Now remember, this is not a monomial. Okay, so a polynomial is defined as having terms with positive counting exponents, or your exponents have to be whole numbers. Well, technically this belongs on the top, and so this is not a whole number, that's an integer. So this could go on infinitely, but our job is to find a third derivative. So now that I've written it in an easier to handle fashion, I get a negative 10 x to the negative 3. My second derivative is going to be a positive 30 x to the negative 4. And then my third derivative is going to be a negative 120x to the negative 5. So you can see it's just going to go on forever and ever and ever and ever. Okay? So we're going to do the last two problems on a separate video just because they're word problems.